In problems 12 and 13, we need to write the equation that corresponds to the scale models in the pictures below. These are pretty easy. I have an x and 1 chip, so x plus 1 on the left side. The balance scale represents the equal sign, showing two sides of the equation that have to stay balanced. On the right side, we have 6 chips, so this is x plus 1 equals 6. The scale in problem 13 we have 3 x's, so 3x, and 2 chips plus 2 equals 8 chips on the right, so 3x plus 2 equals 8. We don't need to solve them, we just need to write the equation to represent the model according to the directions. These we need to solve, so solve each of the following balance scales. There's a couple different ways to do it. We could use the model or the equation. I'm going to do it both ways. Let's write the equation on the right. We have, for number 14, we have an x plus 2 negatives, so x plus negative 2 equals 4 positives on the right. So I can isolate the variable x by adding 2 positives to both sides, because minus 2 plus 2 is 0, so we get x equals 4 plus 2 is 6. And then to check it, if x is really 6, 6 plus a negative 2 should equal 4. The signs are different, we find the difference. 6 minus 2 is 4, and the positive 6 is farther from 0, has a greater absolute value than the negative 2, so 4 equals 4. That checks out, so x equals 6. If you were to solve it with the model, you would create 0 pairs. So I need to add 2 positives to create 2 0 pairs here. So I add 2 positives to the right side, and we get x equals 6. Okay, number 15, we have on the left side of the equation we have 7 chips, so 7 equals, and then on the right side we have 3 x's plus 2 negatives plus a negative 2. I want to isolate x, so I need to get rid of that negative 2 first with the positive 2. That's 0, so we have 9 equals 3x, and then I undo this multiplication with division by 3 to get x equals 3. Then let's check it. 7 equals 3x plus a negative 2. If x is really 3, then 7 should equal 3 times 3 plus a negative 2. 3 times 3 is 9, and 9 plus negative 2 is positive 7, because signs are different. We find the difference. 9 minus 2 is 7, and that positive 9 has a greater absolute value than the negative 2, so positive 7 equals positive 7. So x does equal 3. If we were solving it with the model, we would solve it this way. Create 2 0 pairs by adding 2 positives here to get rid of these chips on this side. So we have to add 2 positives on this side. And then we want to know what 1x equals, not what 3x equals. So we need to break this up into 3 equal groups. And if I sort the left side into 3 equal groups, there are 3 in each group. So each x equals 3 chips. That's the way you show division on a model. Equal groups. So x equals 3, positive 3. Number 16, solve and check. Well, now we have 83 minus x. There's a couple different ways to do this. Maybe the most straightforward way is just to add x to both sides to make this equation a little simpler. Minus x plus x, whatever x is, will equal 0. So we have 83 on the right side equals, on the left side we have 19 plus x. And then to isolate the variable x, we need to get rid of this 19, so subtract 19 from both sides. 19 minus 19 is 0, so we get x equals 13 minus 9 is 4, 7 minus 1 is 6. So x equals 64, but let's check it. 19 equals 83 minus 64. Borrow here. 13 minus 4 is 9, and 7 minus 6 is 1. So 19 equals 19, so that checks out. So x equals 64. And we're not going to have enough time on this video to do 17, so I'll do that on the next video.